Hello everyone, welcome to Science with Koala. And in this video, we'll look at converting the number of particles to the mass and vice versa using the Avogadros number. So in the previous video, we discussed that the number of moles, number of particles, and Avogadros number can be put in one formula, which is number of moles is equals to number of particles divided by the Avogadros number. So if you haven't watched the video, please click on the link in the description below. So now let's look at how we can convert number of particles to mass. We need to remember that number of moles can be determined by two formulae, which are number of moles is equals to mass over molar mass, and number of moles is equals to the number of particles over the Avogadros number. So if we look carefully, the number of moles is the bridge. So we can write this as mass divided by molar mass is equals to number of moles. And the number of moles again is equals to number of particles over the Avogadros number. So the common thing here is the number of moles. So for us to convert the number of particles to mass and vice versa, we need the number of moles. Why? It is the bridge. So if you want to move from here, number of particles, to the mass, you need to first find the number of moles, then you get to the mass. And vice versa, you have to do the same. Start with the mass, determine the number of moles, then you get to the number of particles. So let's create a gateway between the number of particles and the mass. So here's a gateway that we have created. So number of particles is here. So if I want to move from the number of particles to the number of moles, which is here, I need to divide the number of particles by the Avogadros number. That's when I can get to the number of moles. And now, once I get to the number of moles, if I want to get to the mass, I'm going to multiply the number of moles, which are here, by the molar mass of that compound or element. So first, divide divide the number of particles by the Avogadros number, you get the number of moles. Then, once you get the number of moles, you multiply by the molar mass. So, number of particles uh, is divided by the Avogadros number. I get the number of moles. Once I get the number of moles, I multiply them by the molar mass. I get the mass. So this is how we can cross from number of particles to the mass. What about the other way around? If I'm moving from my mass, if I'm moving from the mass and going to the number of moles, I first divide the mass by the molar mass. So mass divided by the molar mass is equals to the number of moles. Once I get my number of moles, if I want to get the number of particles, I say number of moles multiplied by the Avogadros number is equals to the number of particles. So this is what we'll be using throughout our discussion. So let's see how we can apply this using examples. Let's start with the first conversion, and that is moving from the mass going to the number of particles. Once we're done with that, then we'll also look at examples that will involve moving from the number of particles to the mass. So let's do the first example. Example number one reads, how many molecules of boron are in 14.32 grams of BH3. Okay, what do we do? Remember, we discussed to say number of particles over the Avogadros number gives us the number of moles, of which we have said the number of moles is the bridge. So once we determine the number of moles, we're going to use it to uh, determine the mass of an element or a compound. So how are we moving here? So we have information that is in form of mass. So we're going to determine the number of moles first using mass over molar mass. Then once we determine the number of moles, we can use that to get to the number of particles. So let's begin. Data, number of moles unknown, mass 14.32 grams, molar mass. What's the molar mass of boron? So let's determine the molar mass, BH3, number of atoms, 3, relative atomic mass of hydrogen, 1, boron, uh, number of atoms, 1, relative atomic mass, 11. So we get 3, get 11. So we get 14 as the molar mass of boron. So we add units grams per mole. So 14 grams per mole. Right? The formula number of moles is equals to mass over molar mass. Number of moles is equals to 14.32 grams divided by 14 grams per mole. So the grams get cancelled. And what do we get? Number of moles is equals to 1.02 moles. So now we need to find the number of molecules. To do that, we say number of moles is equals to number of particles over the Avogadros number. Then, once we do that, we have 1.02 moles is equals to number of particles all over 6.02 by 10 to the power 23 molecules per mole. Okay, so once we do that, the moles will get eliminated. Then when you cross multiply, number of particles is equals to 6.14 by 10 to the power 23 molecules. Supposed to finish that, I just don't have space, so it will be, let me just rewrite that. Okay, so number of particles is equals to 6.14 by 10 to the power 23 molecules. Yeah, that's better. So these will be the number of molecules found in 14.32 grams of boron. Now, let's look at example number 2. Example number 2 reads, how many molecules of chlorine, CO2, are present in 20 grams of chlorine gas, CO2? What's the first thing we do? We need to remember that we are trying to move from number of molecules to the mass. So number of particles over the Avogadros, sorry, not number of molecules to the mass, but it's actually the mass to the number of molecules. So we need to remember that mass over molar mass is equals to number of moles. The number of moles in 10 equal to the number of particles over the Avogadros number. Okay, so now let's first determine the number of moles from the formula of number of moles is equals to mass over molar mass. Data, Number of moles unknown. What's our mass? 20 grams. What's our molar mass? Our molar mass, chlorine is diatomic, so CO2, that is 2 multiplied by the relative atomic mass, which is 35.5, gives us 71 grams per mole. So this will be 71 grams per mole. Okay. Right. So number of moles is equals to mass over molar mass. We have number of moles is equals to 20 grams divided by 71 grams per mole. We're getting our number of moles as, when you divide 20 grams over 71 grams per mole, you're going to get 0.28 moles. So the grams did get cancelled. So now that we found the number of moles, what do? We use the formula number of moles is equals to number of particles over the Avogadros number. We have 0.28 as our number of moles is equals to number of particles. The Avogadros number 6.02 by 10 to the power 23 molecules per mole. So number of moles will get cancelled. Then when you cross multiply, number of particles is equals to 1.69 by 10 to the power 23 molecules. So these are the number of molecules present in 20 grams of chlorine gas. Let's look at example number 3. Example number 3 reads, given 25 grams of oxygen gas, calculate the number of oxygen molecules present. Given 25 grams of oxygen gas, calculate the number of oxygen molecules present. So moving from mass to the number of particles, which are molecules. So number of moles is equals to mass over molar mass. So once we determine the number of moles, we are going to use the number of moles to determine the number of particles, using the number of moles with the Avogadros number. So let's begin. Data. Number of moles unknown. Mass 25 grams. Molar mass. Oxygen is diatomic. Oxygen gas is diatomic, so get the relative atomic mass. Which is 16, multiplied by the number of atoms present, which is 2, to give us 32. Then for molar mass, remember, units are added, grams per mole. So this will be 32 grams per mole. So the formula is number of moles is equals to mass over molar mass. Number of moles is equals to 25 grams over 32 grams per mole. Have this out. What are we getting as our number of moles? We're going to get number of moles is equals to 0.78 moles. And we use our formula, number of moles is equals to number of particles divided by the Avogadros number. 0.78 moles is equals to number of particles divided by 6.02 by 10 to the power 23. We've got molecules there, so molecules per mole. So when you cross multiply, number of moles get cancelled. Number of particles you're going to get is 4.70 by 10 to the power 23 molecules of oxygen. So now let's look at the next type of conversion. What about if you're trying to move from molecules and you want to get to mass? what do we do? Let's look at some examples. Example number one, I'm converting number of particles to mass. If a sample contains 3 by 10 to the power 23 atoms of carbon, what is its mass in grams? So same thing, remember, number of moles is equals to number of particles over the Avogadros number. So once we determine the number of moles, we can use the number of moles to determine the mass by using the formula number of moles is equals to mass over molar mass. So let's begin. What's our data? Number of moles unknown. Number of particles 3 by 10 to the power 23 atoms. The Avogadros number. So since we're using atoms, it will be 6.02 by 10 to the power 23 atoms per mole. All right. So number of moles is equals to number of particles divided by the Avogadros number. Number of moles is equals to 3 by 10 to the power 23 atoms divided by 6.02 by 10 to the power 23 atoms per mole. So the atoms get cancelled out. Number of moles, what do we get as our number of moles? We get 0.5 moles. Once we found the number of moles, we use the formula number of moles is equals to mass over molar mass. 0.5 moles is equals to the mass. What is the molar mass of carbon? So if you check on the periodic table, you will find that carbon has a molar mass number of 12. And in the previous video, we discussed to say that the mass number is equivalent to the molar mass. Okay, so with the exception that molar mass, you are going to add units, grams per mole. So this will be 12 grams per mole. So when you cross multiply, the moles get cancelled. Mass is equals to 6 grams. So that's how you can determine the mass of a sample containing 3 by 10 to the power 23 atoms of carbon. Okay, let's do the next example. Example number 2 reads, calculate the mass of 2 by 10 to the power 25 molecules of methane. How do we do that? How do we get the mass from the number of particles? First things first, you need to first determine the number of moles using the formula number of particles divided by the Avogadros number is equals to number of moles, which the number of moles is equals to mass over the molar mass. All right, so data, number of moles unknown, number of particles 2 by 10 to the power 25 molecules. The Avogadros number is equals to 6.02 by 10 to the power 23. Since we're using molecules, it's molecules per mole. Number of moles is equals to number of particles over the Avogadros number. Number of moles is equals to 2 by 10 to the power 25 over 6. Grab that. 6.02 by 10 to the power 23 molecules per mole. And we're going to have molecules there. So we made with number of particles. We remain with number of moles when we cancel out the molecules. So how many moles are we getting when we divide? We are getting 33.2 moles. And we use this same number of moles to determine the mass of methane. So we say number of moles is equals to mass over molar mass. We have 33.2 is equals to m. What is the molar mass of methane? So we can find the relative molecular mass by 4 by 1 is equals to 4. 1 by 12 is equals to 12. And we get 16 grams per mole. Let me write that properly. There's enough space there. We get 16 grams per mole. So we have here, I'll put units here, 33.2 moles, and here 16 grams per mole. So the moles cancel out. What mass do we get? We get 531.2 grams. Okay, now let's solve the last example. Example number 3 reads, the sample contains 4 by 10 to the power 22 ions of calcium. What is the mass of calcium in grams? Okay, first things first, we need to determine the number of moles using two formulae. Number of particles over the Avogadros number is equals to number of moles. Once we determine the number of moles, we use it to find the mass. Using the formula, number of moles is equals to mass over molar mass. Data. Number of moles are known. Number of particles, 4 by 10 to the power 22 ions. The Avogadros number, 6.02 by 10 to the power 23 ions per mole. Number of moles is equals to number of particles over the Avogadros number. Number of moles is equals to 4 by 10 to the power 22 ions divided by 6.0 times 10 to the power 23 ions per mole. So the ions cancel out. We get number of moles as 0.066 moles. So we can now use the formula number of moles is equals to mass over molar mass. Our number of moles is 0.066 moles. Mass, molar mass of calcium, remember what we said, the mass number, which is 40. So mass number is equivalent to the molar mass. So 40 is equals to 40 is equivalent to 40 grams per mole. So we add units, grams per mole. So where do you get the mass numbers? You get them on the periodic table. Other periodic tables will show the mass number at the bottom. Other periodic tables show the mass number on top. Okay. So when you cross multiply, number of moles get cancelled. What are we getting when you multiply? You get mass as 26.4 grams. And this is where our lesson ends. Please don't forget to like, subscribe, and share. And you can also leave a comment in the comment section. Thank you very much. Till next time, please stay blessed.